And so recording, and then I'll share. Okay. So this is our TBL hub. So I have uploaded the carbohydrate metabolism. So if you're going to look on the TBL hub on our group page or on our class page, oops, talaga to. You will notice that I have already uploaded this carbohydrate metabolism. Wait lang guys ah. Yeah, using sequencing. Now, meron na po nakahandang mga quizzes in relation to that one. So, you have this one. Ito po is PowerPoint. Okay, ito po, yan. So, you have there the metabolism introduction, which is a PDF file. And then the PowerPoint, then the quiz, which will be available later on. Then, kung ano yung maabot natin, this one, delete ko to kasi edit ko lang to. Yan. So, this is we will be having at least four metabolism here or four reactions here, and then you'll have your exam. And then meron tayo to, same as with the enzymes. I really would like to suggest that you try to go on to the interactive files, yung video from Bioman. It's actually good. Yung mga dati kasing mga previews na website na interactive din, since it's using Flash application to run, it's no longer available. That's why I'm not using it anymore. Okay. So yeah. So let's start with the discussion. Let me just present my screen. Okay. So the first topic that we'll be discussing this time is about metabolism and energetics. Okay. So when you say metabolism, this is the sum of all the chemical transformations taking place in a cell or organism, occurs, which is through a series of enzyme catalyzed reaction that constitute metabolic pathways. Now, take note that each of the consecutive steps in a metabolic pathway brings about a specific small chemical change, which is usually either a removal, pwede ring transfer, or addition of a particular atom, pwede ring compound, or a particular functional group. Wait lang ha, admit ko lang si Patrick. Ayan. Eggs. Okay. Now, so as I mentioned, it can be removing anything. So it may be removal, pwede ring transfer. Remember when we discuss about enzyme activity, it's usually the movement of materials from one part to another. So this time, ito na ngayon yung application na ngayon. So it's either the removal or a movement or addition of different components into the system. Okay. Now, usually the precursor is converted into a product through a series of metabolic intermediates. Now, you call these intermediates as metabolites. Now, take note of the term metabolites. So, yung mga, and also the term precursor. Precursor is the compound prior to a particular structure or a particular compound. So, kumbaga, pwede natin sabihin siya kasi na reactant. Kaya lang take note that we're talking about metabolism, and since we're talking about metabolism, it is a series of reaction. So, aling reaction yon, di ba? Hindi natin pwedeng sabihin reactant. Eh, aling reactant? And dami yan. So, ang tatandaan na lang natin na term for this time, since we're talking about a multiple reaction, it's precursor, metabolites, okay? So, yeah. Now, the term intermediary metabolism is often applied to combine activities of all the metabolic pathways that interconvert precursors, metabolites, and products, which is usually a general lower molecular weight of less than 1,000. So, mababa yung kanyang molecular mass. Okay? Now, if we're going to be dividing or understanding the different components of metabolism, so we have the first one, which is called the catabolism. So, the catabolism is the degrading phase of metabolism in which organic nutrients are converted from smaller and products such as lactic acid, carbon dioxide, and ammonia. And usually, in this process, we release energy. And some of them can be conserved in the form of ATP, yung adenosine triphosphate, NADH, or NADPH, or FADH, and to the rest, which is then going to be converted into heat. So here is your example. So you have your molecules here, carbohydrates, fats, and proteins. It will be broken down to the basic components. Now, on the other hand, we have what we call the anabolism. So this is also known as the biosynthesis, wherein we convert the precursors molecules into large macromolecules. And in the process, this energy is stored in ATP, NADH, NADPH, and FADH. So yung mga nakuha natin mga molecules kanina is gonna be produce now the different proteins that are needed by the body, carbohydrates, and lipids. Okay? Now, if you're going to be combining here, this is the overall metabolism. Okay, so if you will notice, so we get food from our diet, so um, and then it's converted back into the basic nutrients. Then those nutrients are going to be producing now your cell macromolecules. Okay, so this is the combination. And in the process, you can either get a intercycle of the raw materials that are needed to produce the energy or to provide the energy for the system. Okay. Now, on the next slide, you will see here the different pathways, the connections. So some metabolic pathways are linear, some are branched like this one, and which is usually going to give you a different multiple products from a single precursor. For example, carbohydrates. So it will be coming glucose, pyruvate, then papasok acetyl coenzyme A, and then pasok sa TCA cycle. Then afterwards, it can form now the different materials that we need in the body. Okay? So yan. Some of the pathways are also cyclic, like for the case of the TCA cycle. Okay? But one thing is sure that those pathways are usually going to be interrelated. And this is what is the reason that we need to understand about metabolism. That those pathways are going to be interrelated. That is why those can be substituted depending on the need of the body. Okay? So yeah. Now, on the next cycle, we have here the different stages. Okay? So if you're going to analyze it from the macromolecules down to the smallest part or to the lowest part or to the most, what do you call this? Very complex reaction. Ito po yan. So, unang-una, it's mostly hydrolysis. So, your proteins, which will become amino acids, and you all know that polysaccharides will become your mono and disaccharides, and then your lipids will become fatty acids and glycerols, usually through the process of hydrolysis. Now, the second one is converting all, particularly yung sugar molecule into the basic unit, which is pyruvate, which will enter now the TCA cycle. So here it's going to be interconverted from pyruvate to acetyl coenzyme A. Now take note that although we are seeing here the major reaction, you will notice that proteins and lipids can also replenish this. Kaya nga 'di ba kaya nga sabi ko nga sa inyo at the beginning of the semester I've already told you that biochemistry is the best friend of those who are doing diets. Kasi if you know how to use and identify how it will be able to help you metabolize, or let's say in one since na pag-usapan na natin yung catabolism and anabolism, you will know when you're going to be able to maximize your derivation of nutrients or energy from carbohydrates, and then maximizing the amino acids. Now, take note, later on you will see that in the further, as we go further down the line of the discussion of the different metabolism, hindi rin pwedeng sobrang dami ng proteins kasi it will lead to other causes. And then you can also have a fat-rich diet because it can also replenish acetyl coenzyme A, which can enter and produce your needed energy as well. Okay, and then in the stage 3, this is the time we're going to be producing now yung energy natin, yung ATP. So this is in actually in the process of electron transport chain and oxidative phosphorylation. Okay, so dito tayo magpo-produce ng maraming mga ATP talaga. Ito yung mismong concentration natin dyan. And then, also, one of the things that will be produced, of course, is the byproduct and it will be brought out outside the system na. Okay? So now let's, any questions so far, guys, with the first part of metabolism? None? Okay. So let's go on to the next one. So usually, when you talk about metabolism, usually it's the anabolic and catabolic pathways are reciprocally regulated. So it means that usually it can have the synthesis and degradation of fatty acids, pero hindi naman siyang sabay mareregulate. Okay? Pero alam mo yun, pag nasobrahan ka ng isa, it will affect the other one. So, magkakaroon sila na interplay ng kanilang regulation. Okay? Now, catabolic and anabolic pathways are connected that connect the same two endpoints may use many of the same endpoints, but at least one step is catalyzed by different enzyme. Now, you will actually see this when you go to gluconeogenesis. Now, gluconeogenesis is actually a pathway, but if you will notice that this is actually a reverse of glycolysis. Yun nga lang, may ibang part siya na nare-regulate. Okay? And then some of the enzymes may not be the same. Okay? So, hindi lahat ng enzyme ng gluconeogenesis is the same with glycolysis. Okay? And the third one is paired catabolic and anabolic pathways often offer different cellular compartments. Okay? So, usually, hindi po lahat nanggagaling sa isang location lang. So, later on, we will be talking about the location of those different reactions or those metabolisms. So, for example, yung fatty acids sa cytosol, while degradation occurs in the mitochondria. Then you will notice that when we go to the glycolysis, it's happening outside the mitochondria, the cytosol. Then later on, when we go to TCA cycle, which is karugtong naman halos ng glycolysis yan, it will be happening also in the mitochondria. So, iba't iba yung location talaga nila. Okay? Now, let's go now to bioenergetics. So, bioenergetics is the branch of chemistry that focus on how cells transform energy often by producing, storing, or consuming adenosine triphosphate or our energy currency, which is ATP. Now, it also concerns energy involved in making and breaking of chemical bonds in the molecules found in biological organisms. Now, the role of energy is fundamental to biological processes like growth, development, and metabolism. Now, cellular processes like cell respiration, metabolic, and enzymatic processes lead to production and utilization of energy in the form of ATP molecules. Now, the ability to harness energy from the variety of metabolic pathways is a property of all living organisms. Okay. Now, take note that when we talk about the energy, remember we have your potential energy, the kinetic energy. Now, this time we have also a form of potential energy, which is in under Gibbs free energy. Okay. Now, I'm not going to go on to the process anymore with the potential and the kinetic because this is already supposed to be basic and I hope you already have the necessary background on them. So this time, in terms of Gibbs free energy, we're talking about potential energy that is stored inside those chemical bonds that are available in our compounds. Now, in the Gibbs free energy, this is usually associated with the chemical reaction that can be used to do work. Okay, so the free energy is the sum of the enthalpy plus the product of the temperature and the entropy of the system. So ito po yung kanyang formula. Delta G is equal to delta H. Okay, yung enthalpy and then the product of the temperature and the entropy of the system. Okay, so let us identify the different thermodynamic quantities. Okay, so the first one is free energy. So usually guys, ito yung sa delta G, yung mismo kinocompute natin. So thing to remember when you see a chemical reaction, usually a reaction will be happening or a specific reaction. Tapos usually it can denote how much energy is available on that particular energy. We will show that later on. Okay, so thing to remember is that for a negative delta G, the energy is released. And if it is energy released, it's exergonic or exergonic. Okay? Parang exothermal, exothermic, endothermic. But this time, since we're talking about energy, it's exergonic. Now, if it is positive, then therefore it's endergonic. It means energy is being absorbed by the system or energy is being applied into order for that reaction to take place. Okay? So that's the first one. So the second one is the delta H. So delta H is the heat from the conversion of the reactants to the product. So if the delta H is negative, therefore it means that the reaction releases heat and it is exothermic. Okay? And if delta H is positive, therefore, it is absorbing the heat from the surrounding. So parang for example, pag gumamit kayo ng Clorox, you will notice pag namuti siya, medyo mainit yung pakiramdam sa kamay ninyo. And if you use naman yung oxalic acid, for those who are using oxalic acid, you can actually test this. Punta kayo lang kayo sa kasuking tindahan, bili kayo ng oxalic acid, lagay ninyo dun sa tubig, mapapansin niyo yung tubig lumamig. Okay? That's because yung oxalic acid is endothermic. It needs heat in order for it to react. Okay? And the next one is delta S, the change of entropy, or also known as disorder. So that's usually the results of a reaction. Now take note guys that usually for reactions to happen, it's not on an orderly manner. Hindi yan yung okay pila-pila si reactant, okay pila-pila, tapos magre-react sila, tapos sila na or compound na siya. No, it's actually that a different way. It's more of a disorder. So, labo-labo yan dyan. Halo-halo yung mga iba't ibang mga materials in the space. Okay? So, for example, sa loob ng cell, labo-labo yung mga carbohydrates yan. Tapos, papasok si enzyme. So, pag may nabangga siyang sakto sa kanya, then magre-react. Pero kung wala, wala. Okay? So, the more entropy, the more disoriented or the more disorder that is available, the more chances of having reaction. So, therefore, if it's a positive value for delta S, then it's going to be having a positive entropy, then more reaction. Okay, will happen. Okay, so yeah. So here are the things to remember in the terms of the unit. So delta G and delta H usually is in joules per mole or calories per mole, which is equal to 1 calorie is equal to 4.9194 joules. And for entropy, which is S, it's joules per mole Kelvin. Okay? Now, I know you're saying like this, guys, hindi ko na kayo pa kukomputein. Baka natakot kayo, ma'am, math na naman. Yes, well, konting math, pero ano lang, basic na addition po. Hindi tayo po mag-major na i-compute nyo yung mismong component. No, hindi po. Basta maintindihan nyo lang po what would happen if you're gonna be talking about the temperature, what would be happening if the temperature is increasing or what would happen to the reaction. Okay? So yan. So kalma lang tayo. Huwag muna tayong don't let our emotions get ahead of us. So hindi po tayo pagpapaalalayan. Usually, yung higher thermodynamics, naman yan, sa mga major po yan ng mga chemistry na. Okay? So yan. So you say nyo, maintindihan nyo lang that this is actually gonna help in the reaction in our metabolism. Okay? Now, let's go to some of the application of thermodynamics in the living organism. So, unang-una, living organisms cannot create energy from nothing. Okay? Then, second, living organisms cannot destroy energy into nothing. And living organisms may transform energy from one form to the other. So, if you will notice, this three statement that I mentioned here is actually the basic of the first law of conservation of energy. Okay? Energy cannot be created nor destroyed, but it can only transform from one form to another. Okay? So actually, it's also the same thing that is being followed by organisms. Hindi tayo isang snap lang, bigla ka na lang lumabas, di ba? It has to come from somewhere else. Okay? Then, in the process of transforming energy, living organisms must increase the entropy of the universe. Okay? So, yan. And then at the same time, in order to maintain the organization within themselves, living systems must be able to extract usable energy from the surrounding and release useless energy, which is in the form of heat, back into the surroundings. Okay? So, yan yung pumapasok na kaya tayo kailangan kumain sa umaga or kailangan natin kumain because we need to extract usable energy from the surroundings. Okay? That's why we eat. That's why we drink because we can be needing it for our motion, for our movement, okay, or for our daily lives. And then afterwards, i-release natin yan. It's either your carbon dioxide, tapos pag nag-workout ka, you release your heat and then yung perspiration. Those are usually forms of things that are being released. Okay? Now, in terms of equilibrium, let us review the knowledge of free energy and equilibrium. Now, in order for the chemical reaction, cells usually need sources of free energy. Okay, so kailangan natin ng sources of free energy. Now, you can gain this free energy from non-equilibrium systems moving toward equilibrium. Okay, now usually free energy is governed by the equilibrium constant KEQ. So nakita na naman natin si KEQ. Now remember, KEQ is usually related for an equation. Okay? Equilibrium constant kasi yan. Now usually in the KEQ, so let's have an example. So you have here the reaction A, sorry, let me just use a pointer instead. Okay? Yan. So you have A to the A plus B to the B gives you a reversible reaction of C to the C and D to the D. Okay. Now, given this one, if you recall back our equations prior to that, we were able to come up with the formula. Yan. KEQ is equal to C to the C concentration, uh, the concentration of D to the number of moles in D over concentration of A raised to the coefficient of A and concentration of B to the coefficient of B. Okay? So usually this is how we get the K equivalent or K equilibrium. And then if you're going to get the standard free energy, okay, so you're going to get now your standard free energy, ito po yun, is equal to the minus RT ln the product of the concentration, and then you have here the K equivalent or the KEQ. Okay, now given that KEQ here is equal to this formula, we can actually substitute it into here, giving you the formula now that you have uh, your standard free energy is equal to negative RT ln open parenthesis then the K equivalent formula. Okay? So that this is actually the way of getting the alternative mathematical way of expressing equilibrium constant. Now, why do we need to go into this one? Because this will actually help us in understanding the amount of energy. Okay, so if you're going to look at the table here, this is actually showing the relationship between the standard energy, okay, ito, okay, and the equilibrium constant. Okay, so the equilibrium constant of a given chemical reaction, let's say for number one, okay, so then yung one, equilibrium constant of one, then the standard free energy of the reaction is going to be zero, and also the amount of energy, K calories over mole here, is going to be also in zero. Okay, now, taga lang. But if you increase the equilibrium constant, Okay. So let's say let's increase it to the uh, to 10 to the 3 here. Okay. So if we increase it to 10 to the 3, the standard free energy changes to a negative. And if the negative equilibrium constant is less than 1, for example, ito naman, 10 to the negative 4. What you will notice is that the uh, delta G, the values is going to be bigger. Okay, remember that we mentioned earlier the relationship between the equilibrium constant and free energy is exponentially relative to the changes made on the energy. Okay, to the standard free energy um, to the equilibrium. Okay, so for example here, so yan, pag yung k-equilibrium nyo masyadong mataas, yung delta G natin is negative. And then pag masyado naman mababa, it's gonna be mataas. Okay, now take note, what does this mean? So remember, okay, so if it is going to be based on the table that I showed you earlier, the free energy of the equilibrium constant usually determines the spontaneity. So ibig sabihin gaano kabilis or gaano diretso yung reaction. Remember spontaneity. Remember we're talking about series of reactions. So pag series of reactions siya, pag naging positive siya, hindi siya tutuloy. Okay? So, yun yung epekto nun. So, make sure that, so ang target dito natin para magtuloy-tuloy yung acting mga reactions on the pathway, it's really advisable that the um, KEQ should be negative. Okay, I mean it's less than 1, so that we'll be having a forward reaction. Then if it is 0, therefore it's going to be an equilibrium. So, ibig sabihin, equal lang ang movement. Hindi sasabihin na wala na pong gagalaw. It's just an equal movement of, you'll be able to get the same amount of reactants and products. And if it's going to be positive, it's going to be a reverse. Okay, so you're going to go back to the precursors. Okay? So yeah. So this is going to be what the table is showing all about. Now in the next slide, so you will notice here that this table is actually describing the energy changes from some chemical reactions. Ito yung sinasabi ko sa inyo kanina earlier. So if you're going to look here on the table, you will notice that the hydrolysis reactions here, sabay si hydrolysis ito. So si hydrolysis here. Okay? Okay, so if you're going to notice that hydrolysis, tapos of acid anhydrides, esters, and then you have also anhydrides here. Okay, okay, acid anhydrides. Usually, what you'll notice that there is a relatively large uh, changes in the standard free energy. Okay, while the complete oxidation of here, if you're going to look at the bottom here, the complete oxidation of organic compounds such as glucose, here, particularly this one, glucose being broken down to carbon dioxide and water, palmitate, you will notice na masyadong malaki na. Okay, so you're going to see that a very large decrease in the standard free energy. Okay, now take note that however the standard free energy changes that is shown here in this table indicates how much free energy is available from the reaction under standard conditions. So yan po. And then that's the definition of the standard free energy change is to describe the energy released under the conditions existing in cells. And an expression of the actual free energy change is essential for the standard free energy change to be sufficient. Okay? So, yeah. So, mapapansin nyo guys, every reaction that's happening is going to release or absorb energy in the process. Okay? So, yan. So, usually, pinagsama-sama yan to come up. You can actually compute for a a particular amount of energy that's going to be either released or absorbed in a chemical reaction. Okay. So now let's talk about energetics within the cells. Now, so let us consider the energetics, the criteria for the spontaneity of your reaction. So usually for spontaneity, we refer to delta G or the actual free energy change, not the standard free energy change. Okay? Hindi ito po yung tinitingnan natin sa spontaneity. Hindi po ito. Okay? Because um, we consider the relationship or the interconversion of the reaction. So for a given, an example reaction, X is reversible to Y. Okay? So we are going to get the K equivalent of this one. Now, if X is to Y or yung forward reaction is less than 1, it means the free energy, okay, is going to be greater than zero. Yung standard free energy is going to be greater than zero. Okay. So what would be the ratio of x and y would look like at an equilibrium? Okay. So if you're going to look at the equilibrium of this one, so make sure that um, and at the same time, sorry, where would be the reaction be headed if the concentration of x, which is 0 molar, and Y is more sequestering products can derive in unfavorable reaction. Okay, so if you're going to connect this into to the reaction earlier, okay, so you'll be having a forward reaction. Okay, so yeah, okay, so X going to Y. Okay, now if in case you have a reaction that's actually favoring also uh, y going to z, okay, so you will actually going to go forward into z as well. Okay, so ito yung sinabi ko sa inyo, multiple reactions. So if in case you are a more of a favorable reaction, you will go forward and forward until you reach z. Okay? And then you will need to convert it to y. So mapipilitan siya mag-convert to y kahit na yung concentration ni x is zero because of the favorable reaction. Okay? Now, if y to z is favorable, so kung ito namang si y mismo, okay, ang mag-favorable to z at nabubusan na si y, force si x to y na mag-react. Okay? So, ganyan po yung mangyayari sa energetics natin sa cell. Medyo magulo? Nakuha po ba? Question, guys? Pasensya na, waiting ako dito sa baba kasi dito yung isang maliit na monitor ko. Sige, wala. Okay, now, usually the actual free energy changes depends on the reactant and product concentrations. Yan. So given that you have the K equilibrium is at constant, so you have your reaction there. A plus B equals to a reversible reaction of C and D. Okay. And given that K equilibrium is equal to the formula of the K equilibrium formula here. Now, therefore, you're going to be having mass action ratio. So, itong mismong ito na ngayon is equivalent to the mass action ratio, which is Q. Okay? So, the actual free energy change now is the free energy, tapos yung state of free energy, plus RT ln, then K equilibrium. Now, remember, K equilibrium is this formula. Yan. And then, since this is already equal to mass action ratio, we can actually simplify it further into this formula. Okay? So, if in case in the reaction towards equilibrium and delta G is negative, the negative of delta G becomes less and less, more or less, eventually zero when equilibrium is reached. Okay? So, yan. So, ito na ngayon yung updated natin na formula. Okay, so it usually, if it is on the negative side, it will continue. Remember, favorable yung negative, till it reaches zero when it is already in equilibrium. Okay? Ganito nangyari siya. Anyways, so let's have example of standard free energy. Wait lang guys ha. Ayan. Although nakita nyo naman to sa ano eh. Hindi siya nawala. Ayan. Okay, so usually, another thing to remember about the characteristics of free energy, that it is additive. When you say additive, it is actually going to be yung mismong energy that is coming from A to B. Okay, so for example, yung first reaction, yung A to B, meron siyang sarili niyang energy na in-apply. And then, B to C, meron siyang another energy. And then, what would happen is that in summary, all of that energy from A to C will be added up. So an example of this one is the reaction of glucose and phosphate forming now glucose 6-phosphate and water. So yun yung first reaction. Pero meron pa siyang subsequent reaction wherein the ATP is gonna be consumed in the process kasi para makapag-add siya ng phosphate group. So kasama po ito. Okay? And then the final product will be ATP plus glucose would give you ADP plus glucose 6-phosphate. So ito yung summary or yung mismong end product niya. Okay? Now, as I mentioned earlier, each one has its own energy currency or yung kanyang positive delta G or yung delta G niya. So here, yung free energy, standard free energy for glucose 1, glucose and phosphate, pyrophosphate, is 13.8 kilojoules per mole. So this is a positive one. And then the other one, yung ATP, to change it to ADP to pyrophosphate, is going to be negative 30 kilojoules per mole. So if you're going to add them together, since it's additive, so the final free state now is going to be negative 16.7 kilojoules per mole. So overall, the actual reaction of glucose to glucose 6-phosphate is actually this amount of energy. Okay? So yan po. Any questions so far, guys? Okay, sige. Sige, dahil dyan, let's go to the next topic. Sigurado kayo, ha? Hindi naman sana nanakot ako, guys. Sinasabi ko lang, kasi po, ito na po. Ito na po yung sinasabi ko sa inyo last week. We're gonna be talking about carbohydrate metabolism. Okay? Okay. So in carbohydrate metabolism, we're going to be let me just introduce to you ATP. So remember that ATP is actually made of three components. So you have the phosphate groups here, and then the adenine, the base, the protein base, and then the deoxyribose sugar here. Now, bakit tayo nagkakaroon na, or why are we using ATP? Remember, we also have other call this, we have also other compounds that can also release energy. So actually, this is the one that we have. So if you're going to notice here, we have ATP, then you have also glucose 6-phosphate, which can release energy, which I showed you earlier, diba? 16 siya. And then glycerol 3-phosphate, which is going to be releasing a small amount also of energy. here. And then if you have also phosphocreatine, mas mataas siya, -50. By phosphoglycerate, negative around 50 plus. And then, phosphoenol pyruvate, 60. Now, bakit po hindi natin masyado to ginagamit sa katawan? Or bakit hindi siya yung ginagamit as alternative source? Unang-una, this kind of compounds are actually what we call metabolites. Okay? These are actually used in the reactions. So that's why we have a particular compound. Alam mo, ganun kaganda ang pagkakagawa ng katawan natin that we have a particular compound na siya lang although we can get energy from other forms like NADH, FADH, NADPH, pero sa ATP po, siya po yung readily available and it has a particular process in our metabolism that can actually produce ATP per se. Okay? Yung iba kasi, yung FADH and ADPH is actually going to be produced during Krebs cycle, glycolysis. Sa kanya hindi. Meron siyang specific na process that would allow it to be produced directly. Okay? Meron siyang stand-alone, kumbaga. Okay? So, yeah. So, that's for ATP. Later on, we'll go on to electron transport chain. I'm not gonna go to that one yet kasi po, let's go first yung mismong overall picture. Okay? So, start natin muna si glycolysis. Okay? So, si glycolysis is also known as the Emden-Meyerhof pathway. Okay? Now, glycolysis is a pathway that converts glucose 6 to pyruvic acid. Okay? Now, usually the wide occurrence of the glycolysis in other species indicate that the ancient metabolic pathway, okay, now the reactions that make up glycolysis and its parallel pathway, the pentose phosphate pathway, occur in the oxygen-free conditions of the Archean Ocean, which is in the absence of enzymes, okay, and catalyzed by metal. Now, most organisms. Okay. Now, the free energy release in this process is used to form high energy molecules, adenosine triphosphate, and reduce nicotinamide adenine dinucleotide or NADH. Now, the metabolic pathway does not require oxygen, and a wide currents of glycolysis and other species indicate that it is an ancient metabolic pathway. Kasi po, during the ancient times, the major, actually, it was believed that since the earth was forming, the major oxygen, or not major oxygen, but the major gas that we have during the ancient time was not oxygen, it was just carbon dioxide. It was believed that due to the alien, yung mga meteorites na bumagsak noon sa planet natin, yun yung nagdala ng oxygen. Okay? So glycolysis already was happening to the ancient animals na hindi nag or hindi naman animals, pwede nga sabihin animals because they are considered as animals. Remember, iba't iba yung mga family na animals natin, yung mga microorganisms natin nun. So they are considered as archaic ocean dwellers. Okay? Now, in most organisms, it's usually, it occurs on the cytosol. Okay, so these are actually things to remember. Now, the reason why it's called Emden-Meyerhof, actually in Parnas, EMP na siya. Okay, dati it's this one, pero tinanggap na rin yung ginawa ni Parnas. Okay, so it was originally silang tatlo. Now, in other regions, they also accepted another version of that one. Wait lang. So, bali, the Emden-Meyerhof is actually made of from, and Parnas is Gustav Emden. Oh, sorry. Excuse me. Kanina pang nangangating ilong ko eh. And then, uh, last week pang masakit ang sinusitis ko. Okay, sorry about that. Okay, so this time, so the Emden is actually Gustav Emden, Otto Meyerhof, and Jakub Karol Parnas. Okay, now you actually can refer to as Entner-Dodorov pathway. Okay, kasi siya naman ay meron siyang mga idinagdag dun sa pathway na yon. Okay, so medyo additional information lang regarding about the naming of the pathway. Okay? Pero yung mas ang gagamitin natin sa discussion here is the Emden-Meyerhoff-Parnas pathway. Okay? Now, there are actually two phases in the ATP. Okay? So you have the first one, which is the uh, investment phase. Okay? And then the yield phase. As you can see here, this one. So this one is the investment phase wherein ATP is consumed, or also known as the preparatory phase. Okay? So yan, preparatory phase. And then, I'm not gonna go into that one later on. Isa-isayin muna natin yung mga characteristic. Okay? And then this one is the payoff phase or the yield phase. So usually you have their ATP is produced that originally consumed, and it's characterized by the net gain of energy-rich molecules ATP. Since glucose is leads to two triose sugar in the preparatory phase, each reaction of the payoff phase occurs twice per glucose molecule. This yields 2 NADH for ATP, leading to the net gain of 2 NADH and 2 ATP. Now, bakit 2 NADH and 2 ATP? Kasi po yung dalawang ATP ginamit nyo na una during the investment phase. Okay? So, yan. So, this time, let's go on to the specifics. Okay? So, ito yung sinasabi ko sa inyo. You're going to be going back to this one when you go to higher nursing also. Okay, so unang-una po is the first one. You have their glucose molecules. You're going to have hexokinase. So the first step is the phosphorylation of glucose by hexokinase. So this is actually a family of transferase to form now glucose 6 phosphate. Sensya na kayo, maingay talaga yung pusa ko. The reaction consumes ATP in the process. Ito yung part na una tayong gumamit ng ATP. Okay? So, it actually acts to keep the glucose concentration low, promoting continuous transport of glucose into the cell through plasma membrane transporters. In addition, it blocks glucose from leaking out of uh, the cell lacks transporters for G6P. So, pag once na-absorb na ng cell yung G6P, hindi na po siya lalabas ulit sa cell. Okay? So, this is actually the phosphorylation or phosphorylases. This is the first part of your glycolysis. Now, the second one, okay, so you have now your G6P is going to be changing it via the enzyme phosphoglucoisomerase. You're going to change G6P into fructose 6-phosphate. Okay? So, i-rearrange mo lang siya. Ibahin mo yung isomer, i-change mo siya into its isomer fructose. Okay? So, and now, take note, I added this information because kung meron naman extra fructose sa katawan, pwede siyang pumasok dito. Okay? So, ifo-phosphorylate lang po yung fructose, pwede po siyang pumasok sa system na to. Okay? The change, as I mentioned, it is isomerization. Okay? So, the enzyme that is needed is phosphoglucoisomerase. Okay? Now, the third one, you have now your fructose 6-phosphate, your F6P. It will now be adding another ATP. Okay? And then the enzyme is phosphofructokinase. Okay? So this is the second ATP that we consume. Okay? So this time, hindi na po isa lang siya, dalawa na yung phosphate na harap niya. So it's gonna form now fructose 1,6-biphosphate or also known as F16BP. Okay? So yun yung mga, these are actually their simplified names. Now, usually this is irreversible. Okay? It's also irreversible in the gluconeogenesis. This is actually a regulation point. Okay? Now, this when we say regulation point, titigil siya. This is where we control the flow. Okay? And this is also a rate limiting step. Pag mataas, forward. Mataas ang concentration nito, it will actually slow down the formation. Pag mababa po to, forward po siya. Okay? Yan. And the next step, this is actually where we divide now your fructose 1,6-biphosphate into two 3 molecule sugar. So this is actually changing it into 2 aldose sugar. Yung isa po is dihydroxyacetone, and then it is the other one is glyceraldehyde 3-phosphate. Okay, so DHAP and GADP. The enzyme that is used is classified under lyase, and the enzyme name is fructose biphosphate aldolase. Okay, so yan po. Now, this is actually the end of the investment phase. Now, here, after this one, ito pong si DHP ang mag-change. Okay? So, si DHP po, it will be changed into glyceraldehyde 3-phosphate. Now, I'm not gonna go through the process of saying saan nagpunta. Hindi ko na po iisahin yung mechanism. Ang concentration natin dito guys, para matandaan ninyo is ano yung nangyayari. So, ano yung mga reagents, ano yung enzyme, tas ano yung naging product. Then, hindi na kailangan na sabihin na yung double bond is nagpunta dito. Basta tandaan ninyo, nag-isomerase siya, it changed the structural, the double bonds to make it glyceraldehyde. Okay? So, kanina nasa gitna si double bond oxygen, si carbonyl. Now, naging terminal siya to become glyceraldehyde 3-phosphate. Now, this time, at this point, dalawang units na po yung inyong glyceraldehyde. Okay? So, from this point onward, times 2 na po lahat ng products natin. Okay? Next. So, here, although you will see the isa lang siya, guys, again, sabi ko nga sa inyo, from this point forward, times 2 na siya. Okay? So, you will see only one in the reaction nga lang. So, this time, you have glyceraldehyde 3-phosphate, GADP. It will actually now be consuming, or it will now be releasing hydrogen in the process. Okay? And adding phosphate, pyrophosphate. So, the pyrophosphate will be attaching here. Okay, to forming now 1,3-biphosphoglycerate. Okay, so if you will notice, the style that is happening in glycolysis is dagdag ng phosphate, then afterwards putol yan. Okay, so ito yung mangyayari to. Here, nagdagdag tayo ng another phosphate, but not by ATP, but it's actually by NAD and pyrophosphate. Okay. So yung hydrogen is actually coming from the carbonyl here, from the carbonyl. Okay, so yan. So the enzyme is glyceraldehyde phosphate dehydrogenase, which is classified as an oxidoreductase. So you reduce glyceraldehyde, oxidize NADH. Okay, so yan. Sorry, the hydrogen to reduce NAD is reduced, and then the other one is oxidized. Here, next is the 1,3-biphosphoglycerate, yung 1,3-BPG. So this time, the enzyme that we use is phosphoglycerate kinase, or PGK, which is a transferase. So we're actually going to be uh, producing the first ATP in the process. Okay, so yun yung unang ATP. So we remove the ATP from the molecule, from the first carbon, and we transferred it to the ADP. Okay, so yan. So this is the first ATP production. So take note of that one. Okay. Okay, next one is you have 3-phosphoglycerate. Okay. Now, in 3-phosphoglycerate, what would happen here is you're going to change it to 2-phosphoglycerate by moving phosphate into the second carbon here. Okay? Kanina nandito siya, nilipat siya dito. And then afterwards, you have your two phosphoglycerate, and then you're going to have an enol. When you say an enol, you have a double bond within the system. Okay, and it's going to be forming now the phosphoenol pyruvate. Okay. So take note that it's actually a conformation. Wala namang, you remove hydrogen from the compound, okay, forming the double bond. And then you have the last part of glycolysis. Okay, so you have your phosphoenol pyruvate, and this is the second time in the uh, last phase that you'll be producing an ATP. So the phosphate from the phosphoenol pyruvate is removed. It's added to the ATP. Hydrogen is added into the compound, forming now the end product, which is pyruvate. Now, the enzyme used is pyruvate kinase, which is a transferase kasi transfer niya yung phosphate group from the compound PAP to ATP. Okay? So, yan po. Okay. Now, the three products, gross product, we see gross, guys, kasama na po lahat. Pero hindi pa po natin tinatanggal yung mismong na-consume natin. So, gross product niya is actually for every sugar molecule, you have 4 ATP, 2 NADH, and 2 pyruvate. But, since we consumed 2 ATPs at the beginning during the investment phase, you have now 2 ATP na lang na matitira. Okay? Para ano yun, ginamit nyo yung una, so ibalik nyo yung na-consume ninyo. Okay? Now, how do we regulate the ATP? So, unang-una po, okay, so you have their allosteric regulation. So, during allosteric regulation, usually you have there a high point of ATP. Okay, so if ATP is very, very high, therefore, your reaction, the glycolysis will slow down. But if you have a high ADP, okay, but if in case you have ADP and AMP, na pag taas ang AMP and ADP, ibig sabihin po, yung ATP nyo naubos na. Na-consume nyo siya, nabali na siya, nahati-hati na siya. So therefore, you're going to speed up the pathway. Okay? Now, another one is hexokinase. Okay? Yung hexokinase, which is actually the enzyme that regulates the formation of glucose 6-phosphate, yun yung unang-unang step. Okay? So the first entry point of glucose in the formation of hexokinase, of glucose 6-phosphate, ito po yung magiging ginagawa dito is what we call feedback inhibition. Okay? So what would happen is in case you have a high amount of pyruvate, tapos mataas din yung ATP, pipigilan po or papahinain po yung action ni hexokinase via feedback inhibition. Okay? Now, if in case there is a low glucose 6-phosphate, therefore, hahayaan po si hexokinase na magpapasok ng glucose by converting it to glucose 6-phosphate. Okay? So, yan po. Next one is phosphofructokinase. Now, phosphofructokinase, this is actually the one that is responsible in the formation of fructose 6-phosphate. Okay? So, wait lang guys. Now, it regulates the energy charge of the cell, and it can be activated by fructose 6-phosphate. So pag mababa yung level ng fructose 2,6-biphosphate, then it will allow fructose 6 phosphofructokinase, nabulol na ako, to work. Okay? Then it is inhibited by citrate. Okay, chinecheck ko lang yung notes ko guys. Wait lang. Okay, now how does TCAs work on it? Kasi yung citrate po is part of the TCA cycle. Okay, so it's an intermediate. Now, pag mataas po yung amount ng TCA ng citrate in the TCA cycle, it will actually allow it will actually inhibit the reaction of the phosphofructokinase. Okay? So, pag mataas ang citrate, babagal po to. Pag mababa ang citrate, it will allow the action of phosphofructokinase. Okay? And the last one is pyruvate kinase. The pyruvate kinase is actually the one that is responsible for changing phosphoenol pyruvate to pyruvate. Okay? So pag mataas ang ATP, ini-inhibit niya to. Okay? Ganun po yung nangyari. So pag mataas yung byproducts, stop siya. And then the other one, pyruvate kinase, is also inhibited by acetyl coenzyme A. So remember, one of the products ng pyruvate is it will be changing to acetyl coenzyme A. So pag mataas ang acetyl coenzyme A, inhibit. Pag mababa si acetyl coenzyme A, tataas siya or mag-increase yung reaction niya or mag-proceed yung kanyang reaction. And then the last one is fructose 1,6-biphosphate. So this is feed-forward activation. Okay. So usually what would happen here is that the intermediate is controlled by its own enzyme in system. So hindi po siya end product. Within the system po siya. Remember when we talk about earlier yung kanyang feedback inhibition, usually yung end product po. So ito hindi. So in between po, siya po yung mag-activate po. So it's actually a part of the reaction pathway. So pag mataas po siya, it will actually cause, remember the concept about X to Y to Z? Si X kasi si fructose 6-biphosphate, ito yung nasa dulo na eh. So what would happen is that if in case mataas po si fructose 6-biphosphate, ipupush niya yung reaction. Okay? Kaya dapat po, um, magkaroon ng regulation on the higher part, which is hexokinase. Okay? So yan po yung mga tatlong mga inhibitions that can help in regulating glycolysis. Okay? Any questions so far, guys? Mariel, question? Okay? Sige. Maaga pa. Let's go on. Next is fermentation. So usually these are catabolic reaction that are usually happening without any oxidation. Now, usually this is the process wherein it produces chemical changes to the different organic substrates to the action of enzyme. Now, usually in biochemistry, it is actually happening in the absence of oxygen, and food production can be also happening undergoing fermentation naturally. Okay, so usually the products of fermentation in cell respiration is NADH, which is endogenous, and it's an organic electron acceptor. Now, what you have here is pyruvate, which is a form from sugar through glycolysis, and it produces NAD ion, an organic product, which is ethanol, lactic acid, and hydrogen gas, and also carbon dioxide. Now, for the fermentation, guys, we have, oh, by the way, this is also um, the products that we have here will also undergo what we call oxidative phosphorylation. Now, we have two types of fermentation. You have what we call the lactic acid fermentation or lactate fermentation, and the ethyl alcohol fermentation or ethyl alcohol formation. Okay, so the first one is lactic acid fermentation or lactate fermentation. So meron kasi tayong iba't ibang klase ng fermentation. We have what we call the heterolactic or homolactic. For this one, we'll be concentrating on homolactic. Okay? Kasi it will actually produce only lactic acid. Okay? Pero yung pag nasa labasan ng katawan na pag non-human, so for example, you're gonna be talking about plants, it is heterolactic. Okay? Kasi it's gonna be forming now multiple products in the process. Okay, so usually the formula uh, you have your sugar molecules, and then it's going to be forming now your lactic acid using this formula. Okay, so this is happening in the animal's muscles, and this is the one that is needed when we do our work. For example, nag-workout ka. Okay, so when you do a workout, you need actually pyruvate to make your muscle work. Okay? Now, once you do an action, for example, flex mo yung muscles nyo, ganyan-ganyan kayo. Okay? So, pag ginalaw nyo yung muscles niyo, you already consumed already lactic acid, pyruvate. And then, it actually fermented. The action of the muscle is that it would change the pyruvate into lactic acid. Okay? So, usually, um, depende yan sa muscles mo. Depende yan sa workout mo. Okay? Now, when you do a workout, for example, nag-workout ka after a long time, nagbakasyon ka kasi, hindi ka nag-workout, hindi ka nagagalaw. Tapos pinagawa ka sa PE mo. For example, sa PE nyo guys, pinatakbo kayo pinag-jumping jack kayo ng 30 times. Diba? So usually what's happening, ano nararamdaman ninyo pag natapos kayo mag-jumping jack ng marami? Anyone? Ano nararamdaman nyo pag pina-jumping jack kayo ng matagal? Yes, Mark Diaz. Okay. Saan ang gagaling ang muscle spasm? Yes, Mr. Diaz. Yes. So usually, actually it's not that marami. Yung katawan mo has already produced, gumagalaw ka eh. So therefore, the body will actually tell you, oh, ito lang kailangan ko ng pyruvate to do the work. Okay? Eh yun nga lang, you did the action so much na hindi kinaya yung level. Nagets mo? Alam mo yon, ang daming pinuduce, tapos hindi ka nakakapakuha ng panibagong pyruvate in the process. So what would happen here is yun yung nararamdaman natin, muscle spasm. But what you will notice is that if you continue on with the process, kasi usually yan yung nangyayari, pag nasumakit ang katawan, anong ginagawa? Thank you, Mr. Diaz. Anong ginagawa ng iba? Nagpapahinga ng matagal na matagal. Diba? So what would happen? Bumabalik ulit yung masakit. So what you do, just tama si Mr. Diaz kasi di ba nakita ko yung picture na sinend mo, nag-workout ka. So usually, ang advice nila, you can only rest, bigyan mo lang ng sandali. Or let's say 1 day. Pero you have to continue on with the action. Now, what is that mean? If you continue on with the action, yung level ng pyruvate conversion into lactic acid is going to be nakakasanayan ng katawan. So, mapoproduce niya or mabibigay niya yung pyruvate na kailangan mo, tapos matatanggal ulit dun sa muscles yung lactic acid. Okay? And when that happens, nasasanay. Kaya kung mapapansin niyo, every time you work out, the same amount, di ba? Pag ganun ang repetitions mo, let's say 50 reps ka per day, you will notice that as the time goes by, your body is no longer having those spasms. Hindi na po siya masakit. Okay? Kasi po, nasanay na siya dun sa flow ng lactic acid at saka pyruvate dun sa particular set of muscles ninyo. Okay? Then, pumapasok ngayon yung term na nagpa-plateau kayo. Tama ba, Mr. Diaz? Have you heard of the word plateau? So, parang nasanay na. Parang wala ka na nakikita. 'Di ba? So, kung gano'n na nangyayari, is either you add some weights into let's say, kung nagsi-sit-ups ka, magdagdag ka ng weights, or habaan mo na yung repetition mo. Okay? Yun nga lang, since nagbago ka na naman ng number of either nagdagdag ka ng weights if you're doing uh, your activity or nag-extend ka ng number of reps mo, what would happen is that, of course, i-anticipate mo na magkakaroon ka ng additional spasm again. Kasi nga, dinagdagan mo yon, tumaas na naman yung conversion from pyruvate to lactic acid, tapos mararamdaman mo yung pain. So, ganun lang ulit. Get used to it and then saka ka mag-change. Then before you know it, your muscles are already formed. Yes, Mr. Laberges. Mhm. Mhm. Yes, yes. Yes, thank you for that insight, Mr. De La Beres. Okay, thank you so much. Any others information that you'd like to share? How about Mariel? Baka may gusto kang i-share. Kasi the reason I also have this thing, I mean, back then, I have a friend na talaga sobrang kung makapag-workout. Alam mo yung pag sa office noon, doon sa kabilang office namin, just to share with you, pag wala siyang ginagawa, tapos wala yung mga bosses, may kita mo mamaya siya dyan, nagpo-push up siya, nag-ano siya, ano ba yun? Yung yung ab roller siya, nag-ab roller siya sa gitna ng floor namin at kaya na nakakaloka rin, alam mo yun. Tapos talagang dinidiscuss niya about the muscles niya, kung paano niya napapalaki. Okay, fine. Too much info. Yes, Mr. Diaz. Actually, you just need to convert more. Hindi mo siya mapapaliit, yung conversion mo. Kasi remember, it's a byproduct of the muscle movement. Okay, so you can actually, yes, you can actually drink water, pero it's more on, ano eh, continue with the process eh. Yun lang din yung nakita kong ano dun eh. Um, ano, continue mo lang yung process ng katawan mo. Huwag kang titigil kasi once na bumaba yung amount ng pinoproduce mo, tapos nasanay yung katawan mo dun sa level ng lactic acid sa katawan mo, sasakit ulit siya pag tinaasan mo. So you really have to maintain talaga. And if in case na bumaba ka or hindi biniwasan mo yung activity mo, okay, you have to do it gradually. Hindi ka pwedeng bumalik doon sa dati mo. Let's say, nagwa 100 reps ka kaagad, na nasanay ka nagwa 100 reps ka per per exercise. Hindi ka pwedeng mag 100, you have to start from the low. Mabagal lang na mabagal. Pero usually, ang alam ko lang is you really have to keep on the movement. Yun lang ang alam ko. For that's what I know. Okay? Anything is okay. So yeah. So if you're going to go on to aside from that one, so you also have lactic acid. This is being formed by bacteria. So remember, and some fungi. That is the reason why we're able to come up with yogurt. Yan, yung sugar, yung gatas, it's converted, di ba, sa iniinom natin yung Lactobacillus shirota strain, yung iniinom natin na Yakult. Actually, this is lactic acid. Sensya na, meron kayo. Then you have also, okay. So and then you also have what we call, at ito muna, pakita ko muna sa inyo yung mismong formation. So you have their pyruvate, then the enzyme is lactate dehydrogenase for forming now your lactic acid. Okay. Now, the next one is alcohol fermentation. Now, in the alcohol fermentation, so you have there your glucose molecule, which is converted into ethanol. Although we all know that it is a multi-step process, okay? So if you're going to look here, it's actually changing sugar to pyruvate, then pyruvate to acetaldehyde, and then it's gonna be changed to ethyl alcohol. Okay. Now, take note that this is the reason why we are able to come up with our bread. Kasi kung wala pong fermenters na nilalagay dun sa loob ng ating bread. Baka ano siya, hindi po siya tinapay, hindi po siya tinapay na as in yung pandesal na squishy. It's gonna be forming now what we call parang ano siya, mas matindi pa siya sa cookie. Kasi ang cookie guys, nag-expand din siya sa loob. Yun nga lang, baka ano siya, unleavened bread. Wala siyang ano, ang tigas po nun, para siyang, hindi siya ano eh, hindi siya tinapay, hindi rin siya cookie. Mas matigas pa siya sa cookie ang kalalabasan. Okay? Now, ito naman po din, of course, this is actually the product that we have in wines, beers, and other liquor or yung mga alcoholic beverages. Okay? Now, take note, iba-iba po yung mga, iba't iba po yung ginagamit nilang mga, call this, um, agents, fermenting agents, to give them a different type of texture. Okay? Yung mga, sorry hope you don't mind me asking. And if in case you don't want to answer, okay lang. Has anybody here tried drinking alcoholic beverages? Yung totoo lang. I'm not, Nako, Edison, bawal yan sa katawan mo. Umiinom ka. Masyado malakas ka mo uminom. Mr. Dison, yung tama lang. Yung totoo. Occasionally. Okay, tama lang yun. Kasi ano yan eh, as much as possible, kaaway yan ng ano, ng pagba-bodybuilding. Okay? So yan. Now, usually depende kung ano yung ilalagay ninyo. Depende rin dun sa mismong sugar ng panggagalingan, di ba? Yung mga wines, they have different flavorings. Usually, iba-ibang klaseng materials ang ilalagay nila. Originally, when we talk about wine, you just only have grapes. Now, in other countries like in the US, particularly California, sinasamahan nila ng konting oranges para magkaroon ng citrusy flavor. But remember, citrus is medyo acidic, baka maging acidic yung wine na ginagawa. And then if you're going to call about, ano pa ba? Yung whiskey guys, by the way, is double fermented. When you say double fermented siya, yung unang product, i-ferment mo siya, i-distill mo pa siya para makuha mo yung mismong item na gusto mo. Okay? And then, you also, ano pa ba? Yung sake and yung soju, it's also the same process po. Okay? Distilled po siya. Kaya malinis po siya tapos wala po siyang color. Okay? And then you also have tequila. Okay? For those who haven't known tequila, tequila is actually produced from a family of pineapple. Okay? So yung kinaibahan nga lang niya, hindi siya fresh fruit na i-ferment. Pakukuluan niya muna siya bago siya i-undergo ng, although tama naman, ipapakuluan siya. Pero ang ginagawa nila, parang sinusunog muna nila yung mismong labas nung ah, agave. Agave is a family of pinsan niya ng pinya. It is used in the production of tequila. Okay? So, after nag-ferment na yung agave, yung cooked agave, then i-ferment nila. That's how you get the tequila. Okay? Now, fermentation of feedstocks also includes sugar cane, corn, sugar beets that's used also to produce ethanol that is needed in gasoline. Okay? And then, um, in some fishes, including goldfish and carp, it produces energy when oxygen is scarce. Okay? So, yeah. So, here is actually an explanation how it's going to be happening. So, as I mentioned earlier, you have your pyruvate after going through glycolysis. And then, with the help of the enzyme pyruvate decarboxylase, it's going to be changing it. You're going to be actually removing carbon dioxide in the process here, okay, forming now your acetaldehyde. And then afterwards, it's going to be action by alcohol dehydrogenase, wherein you're going to be having now your hydrogen added into your acetaldehyde, causing and formation of double bond, forming now your ethyl alcohol. Okay? Any questions so far, guys? Kaya pa? Kaya pa, guys? Sige, that's yes, kaya pa. Okay, so this time we're gonna be having pentose phosphate pathway. Now, I'm not gonna go through the specifics, but it's more of a general lang. Okay, so yung mga dapat natandaan lang when we talk about the pentose phosphate pathway. Now, when you talk about the pentose phosphate pathway, this is actually an alternative pathway for glucose oxidation. Okay, remember, kanina we talk about the first one, which is glycolysis. Now, it provides energy into the cell in the form of biosynthesis, and it produces NADPH, and it is happening inside the cytosol. So here is a general reaction of your pentose phosphate pathway. You have glucose 6 phosphate producing now ribulose 5 phosphate, and then to NADPH and CO2. Now, in the pyrophosphate pathway, usually this is actually providing, as mentioned, it's actually important in biosynthesis. Now, it is important in the liver and mammary glands and adrenal cortex, and it produces ribose and other nucleotides. Okay? And it is active in tissues involved in cholesterol and fatty acid biosynthesis. Now, there are actually three stages in the in the PPP. Okay? Sa ibang books dyan, it's pentose phosphate pathway. Yung iba naman, HMP, hexose monophosphate pathway. So, iba't iba po yung pangalan nila. Okay? But for this time, we're just gonna call it PPP, pentose phosphate pathway. So, the stage one is that you have your glucose 6 phosphate to form now your ribulose 5-phosphate. And then later on, it's going to be forming now your, since tatlo siyang unit, it's going to be forming now ribose and 2-cellulose 5-phosphate, and then 2-fructose 6-phosphate, then glyceraldehyde 3-phosphate. Okay? So this is just a summary of that one. Then you can also refer to this slide wherein you have your ribulose forming now the different nucleotides or the different sugars that are going to be needed by the system. So you have here ribulose 5-phosphate, forming now ribose 5-phosphate, or either cellulose phosphate. Now it can actually change into ketolases, glyceraldehyde 3-phosphate, which can become your fructose 6 with the addition of another glyceraldehyde. Yan. So you will notice this is actually where some of the other molecules can be changed. So yung kanina, di ba, from glucose, so marami kang glucose, tapos wala kang fructose 6, pinigilan na yung formation ng pag-produce ng fructose. It can actually happen in the PPP. Okay? Kumbaga, pag pinaslow down na si glycolysis sa PPP, pupunta yung ibang mga sugar molecules natin to change into the different components that is gonna be needed. Okay? So, yan. Ayan ang sabi ko sa inyo. Pag it will enter now your glycolysis in the process. Basta tinigilan si glucose, dito siya dadaan. Okay? Okay. Next one is the gluconeogenesis. Now, the gluconeogenesis is actually the production of glucose. So, this is actually a anabolic pathway that usually occurs in the liver, and it is the reverse glycolysis, which is except for steps 1, 3, and 10, which is irreversible. Now, hindi po tayo nagagamit dito ng ATP but GTP in the process. So, here, now, I'm not gonna go through the same step anymore like I did with the glycolysis, but I'm just gonna show you how it's gonna be, how similar they are. So if you will notice, it's actually the reverse. So yung iba, the same, pareho pa rin. Yan. Except for 1, 3, and 10, you have different enzymes. Okay? Majority is the same except for 1, 3, and 10. Ano yung pinagkaiba? Yung sa step 10, yung kanina sa pyruvate, it's actually changing it to pyruvate to oxaloacetate to phosphoenol pyruvate. Okay? So the enzyme here is pyruvate carboxylase. Just zoom in there. Yan. So if you will notice here, yan. So dyan po siya nagkaiba. Kanina, naging 2 steps yung ano natin. Yan. 2 steps tayo dito, di ba? Isang step to sa glycolysis. So, dun sila nagkaiba. Okay, if you're going to slow down, grow up again, in step 3, phosphofructokinase. Ito naman, fructose 1,6 biphosphatase. Okay? Kasi nga, you're gonna be removing the phosphate group. Okay? And here, it's gonna be glucose 6 phosphatase. Okay? So, yan po. So, halos the same lang, oh. Except for 1, 3, and 10. Step 1 ng glycolysis, step 3 ng glycolysis, and step 10. Okay? Any question with this part? Okay. So let's go now to precursors of gluconeogenesis. Now, your precursors are usually your glycerol. So glycerol can actually come into play. So this is actually happening here. Okay? Dito papasok si glycerol. And then you have lactate, alpha keto acids, and acetyl coenzyme A and precursors of acetyl coenzyme A. Now, yung acetyl coenzyme A, ito po. Dito siya papasok sa part na to. Okay? Kasi acetyl coenzyme A is actually or yung mga components yan ng TCA cycle. Okay? So, take note of that. Okay. Now, how do we regulate that gluconeogenesis? Of course, you have what we call the glucagon. This is actually an allosteric effector, and it's usually being controlled by the high level of ATP in the system. Now, pag mataas ang ATP, inhibit siya. And then fructose, it activates also by fructose 6 biphosphate. Pag mataas ito, glucagon will work. When you know glucagon is the alternative or the opposite of insulin, remember? Insulin and glucagon, these are actually the two enzymes that is responsible for sugar control inside our body. So insulin, pag masyadong mataas, papasok si insulin. Pag nagkakaroon ng fasting, papasok si glucagon. Okay? So yan. So, and then it also is inhibited by phosphofructokinase. Now, another one is substrate availability. When we say substrate availability, you're talking about those other components in the system. So, if you go back here, yan. So, ano ba yung mga substrate na kailangan natin? Pyruvate, oxaloacetate, ito. Okay? So, pag wala po masyadong level or masyadong mababa po ang concentration nitong mga to, babagal si gluconeogenesis. Ganun din if you have a low supply of this one. So pag bumaba po ito, of course, papasok si glycolysis. Okay? Kasi mababa eh. So kailangan niya yung kabilang side mag-work. Okay? And the last one is stimulated by high level of AMP, ADP, and pyrophosphate. Okay? So pag mataas yan, produce tayo. Okay? So next one is glycogen synthesis and degradation. Okay. Now, when you talk about glycogen synthesis and degradation, unahin muna natin si synthesis. But before that, let's have a little bit recall of glycogen. So we all know that you have your glycogen. This is actually this is a polysaccharide, okay, which is actually made of multiple highly branched amylase and amylopectin, or mas mataas yung amylopectin compared to the ratio of amylose. Okay, highly branched siya. Now, take note of the branching. You have an alpha 1,6 glycosidic bond for the branches. And then for the straight chains, you have alpha 1,4. Okay? So, unahin muna natin sa glycogenolysis. So, this is actually the degradation of glycogen. Okay? So, in glycogen genolysis, what would happen here is that you just have glycogen phosphorylase that will act on the glycogen end units. Okay, sa end unit yan. So, what will happen is that it will be adding phosphates on all terminal sugar units. Okay? So, yan. So, puputulin yan ang puputulin yan. So, here, it will be adding now phosphate, glucose 1 phosphate. Okay? So, kung gaano karami yung glucose units na nandito, except until dito guys ha. Pagdating dito, titigil yan. So, kung dito, if you're going to look at the screen here, you will notice you have 1, 2, 3, 4, 5. Okay? So, you have 5 sugars here. Hindi pa po ito terminal. I think kasi kadugtong yan doon sa iba. The rest of the group yan eh. So, ang available na pwede niyang putulin from here is 1, 2, 3, 4, 5. So, you'll be having 5 glucose 1 phosphate. Okay? So, yan yung mga ano niya. Kailangan, yan ang mapuputol niya. Okay? Now, what would happen is that you have still a branch. Now, kailangan tanggalin ang pagkaka-branch noong mismong nung mismong amylase na to, itong remaining part na to. And in order to do that, you will need a different enzyme. Okay? So what we have is a debranching enzyme which is alpha 1,6 glycosidase. Okay? So what will happen is that the alpha 1,6 will be removing or adding hydrogen in this particular bond, removing now one sugar molecule. Now this is, take note that this is the only time that you will have sugar molecule. Hindi po glucose 1-phosphate, hindi po glucose 6-phosphate, but sugar. And once it's already released in the system, it can now enter glycolysis or pumasok siya sa bloodstream natin. Okay? And then once that happens, na wala na yung debranching, tuloy ulit um, yung glucose phosphorylase in action hanggang sa maubos niya lahat yung straight chain niya. Tapos if in case may encounter ulit ng isang branching enzyme, pasok ulit si debranching enzyme, tanggal yung isang yon. Okay, so usually guys, it is the one that is added as a branch. So if in case there are 5 branches, therefore you'll be having 5 glucose as a product here. Okay? So yan. Okay, question so far? Malapit na natin matapos. Okay. Next, the last one is glucogenesis. Okay. Now, glycogenesis. Okay, so or the glycogen synthesis. Now, in the glycogen synthesis, we actually need your UDP glucose. Now, this is actually the carrier molecule that would be needed in the production of your glycogen. So, usually, guys, you already have what we call a glycogen primer. Okay. So you have a glycogen primer. So this is just a globular glycogen or so small, parang maliit na glycogen. So what would happen is that it would continue be adding glucose into the glycogen. So yung mga naka-branch out, yung mga ano, papahabain niya yon. Okay? So it is actually the uridine or UDP glucose that will bring those glucose units into the glycogen primer. And then with the enzyme glycogen synthetase, it will add now your glucose molecules into the terminus or one of the terminals. Okay? And after that, you'll have now UDP. So magdadala ulit si UDP. Parang ano yan eh, naglalaro kayo ng Lego, or yung ano, pinapahaba ninyo yung buntot. Parang snakes and ladders, parang dikit siya ng dikit doon. Okay? So ganun yung nangyayari dyan. Okay, next. After, remember you have to have a branch and you're talking about glycogen. So the next part is kailan magbabranch. So usually inside the UDP, you have their enzymes that will tend to regulate it, telling it that it's time to branch that particular chain. Pag masyado na mahaba siya, it has to undergo the chaining now. So yung chaining nyo is usually what we call an alpha 1,6 to alpha 1,4 to alpha 1,6 transglycosylase or amylo transglycosylase. So what will happen here is that if once you already have reached 20 units or 8 ano pala 20 na 20 since we're talking about glycogen mga 12 units na. Oh, naka-12 ka na. Gawa ka ng panibagong linya. Okay? And then it will add now to a branch forming now your uh, alpha 1,6 bond. Okay? So, ganyan po siya. Okay? So, ito yung long name po niya. Ito po yung kanyang short name. Glycosyl alpha 4,6 transferase. Okay? So, usually that's how you just do the glycolysis. Any questions so far, guys? None? Okay. Wait lang guys. Tingnan ko kasi kung i-discuss natin, teka lang, minsan na yun. Kaya lang kasi it already contains ATP. Okay, it's gonna accept, teka guys. Okay, ganito na lang guys. Kasi po, um, if you're going to start the other one, masyado na marami, I would suggest that we can actually stop the discussion here. We'll finish the discussion next meeting. But you can actually, if you want, you can actually start taking the exam about the bioenergetics. Okay? So, ganun na lang po ang gawin natin. For the remainder of the time, kindly take the exam for bioenergetics. Or you would like to do this next over sa Friday? Asayas? Your comments, guys. Friday na lang. Okay lang naman sa akin. Para at least hindi kayo, guys, hindi biro po yung mga question po dito, ha. So, pangyayari dyan, guys, is tatapusin natin yung buong carbohydrate metabolism on on Thursday rather. So, that would mean group 1 will be doing the presentation on Monday. Okay? So, yun po yung mangyayari doon. Okay lang po? Okay, so be ready for that one. Mga tatlong quizzes po ang nakaready yan dyan. Okay, so ganun po. So I'm just gonna stop the discussion here kasi nga sabi ko sa inyo mabigat na yan. And then we'll continue on Thursday. Okay? Sige. I still need to update yung Duk, natapos mo na ba lahat? Yung mga natin? Yung mga quizzes mo? Mr. Ramos? Wala si Mr. Ramos? Anyways, sige. I'm just going to disconnect now. Kindly review that one. And then I'll see you on Thursday. Okay? Okay, bye-bye.